friends. Welcome to a new topic in chemistry. In this video, we are going to discuss properties of liquid state of matter. As you already know that matter can exist in 4 states. They are solid, liquid, gases and plasma. In this video, we discuss only the properties when the matter is in liquid state. What is liquid state of matter? The liquid state is one of the 3 principal states of matter. The other 2 states are solid and gases. In this liquid state, matter has a definite volume but no fixed shape. Liquid will conform to the shape of its container. This unique property arises from the intermediate intermolecular forces present in liquids, which are stronger than those in gases but weaker than those in solids. The key characteristics of liquid state are: liquids have definite volume. Unlike gases, liquids maintain a constant volume under constant temperature and pressure. Liquids have no fixed shape. They take the shape of their container due to the ability of their molecules to move past one another. Fluidity means molecules in a liquid are in constant random motion, allowing liquids to flow and take the shape of their container. Incompressibility means liquids are nearly incompressible because the molecules are closely packed together. Surface tension is the force that acts on the surface of a liquid, causing it to behave as if covered by a stretched elastic membrane. It results from the cohesive forces between liquid molecules. Viscosity is a measure of a liquid's resistance to flow. Higher viscosity indicates a thicker liquid, like honey, while lower viscosity indicates a thinner liquid, like water. Here are some important concepts. Evaporation is the process by which molecules at the surface of a liquid gain enough energy to enter the gaseous state. Vapor pressure is the pressure exerted by the vapor in equilibrium with its liquid at a given temperature. Boiling point is the temperature at which the vapor pressure of a liquid equals the external pressure acting on the liquid. The liquid state of matter plays a significant role in various physical and chemical processes. Now the question is, at a given temperature, which of the following liquids is likely to have the highest vapor pressure? The correct answer is option 3. Vapor pressure is inversely related to the strength of the intermolecular forces present in a liquid. Benzene molecules interact through dispersion forces, which are weaker than the hydrogen bonds in water and ethanol, and the metallic bonds in mercury. Therefore, benzene has a higher vapor pressure compared to the other liquids listed. What is vapor pressure? Vapor pressure is the pressure exerted by the vapor of a liquid in equilibrium with its liquid phase at a given temperature. Let us understand equilibrium state. When a liquid is in a closed container, molecules continuously evaporate from the liquid surface into the vapor phase and condense back into the liquid. At equilibrium, the rate of evaporation equals the rate of condensation. Vapor pressure is dependent on temperature. Vapor pressure increases with temperature because higher temperatures provide more energy for molecules to escape from the liquid phase into the vapor phase. Volatility is another important property. Liquids with higher vapor pressures at a given temperature are considered more volatile. For example, ether has a higher vapor pressure than water at room temperature, making it more volatile. Next is boiling point. The boiling point of a liquid is the temperature at which its vapor pressure equals the external atmospheric pressure. At this point, bubbles of vapor form within the liquid, leading to boiling. Why it matters? Vapor pressure is crucial in many chemical processes, including distillation and evaporation. Vapor pressure plays a role in weather patterns and the water cycle, influencing humidity and precipitation. Understanding vapor pressure helps explain phenomena in our everyday life, like why puddles dry up and how perfumes evaporate. Let us take an example. Imagine a sealed container which is partially filled with water. As water molecules evaporate, they exert pressure on the container walls. Now the question is, which of the following statements about vapor pressure is correct? The correct answer is option 4. Vapor pressure is the pressure exerted by the vapor of a liquid in equilibrium with its liquid phase. Other 3 statements are incorrect. What is Clausius-Clapeyron equation? It is a mathematical model between vapor pressure and temperature. It states that the natural logarithm of the ratio of vapor pressures at two temperatures equals the ratio of heat of vaporization to the universal gas constant times the difference in reciprocals of the two temperatures. What is surface tension of liquid? Surface tension is a property of the liquid surface that causes it to behave as if it were covered by a stretched elastic membrane. This phenomenon arises due to the cohesive forces between liquid molecules. Let us discuss some key properties. What are cohesive forces? Molecules within a liquid are attracted to each other. At the surface, molecules experience a net inward force because they are not surrounded by similar molecules on all sides. This creates a kind of skin on the surface that resists external force. Another property is minimizing surface area. Surface tension causes the liquid to minimize its surface area. This is why small droplets of liquid tend to form spherical shapes, as a sphere has the smallest possible surface area for a given volume. Surface tension decreases with the increase in temperature and vanishes at boiling point as the cohesive forces become negligible. Some examples are water striders. These insects can walk on water due to surface tension. The cohesive forces between water molecules create a surface strong enough to support the weight of the water strider without breaking. Soap bubbles. When you blow a soap bubble, the surface tension of the liquid film causes it to form a nearly perfect sphere. The soap reduces the surface tension of water, allowing the bubble to stretch and form. Floating objects. A small, lightweight object like a paperclip can float on the surface of water if placed gently. The surface tension creates a supporting force that prevents the object from sinking. Now the question is, which of the following factors would decrease the surface tension of water? Increasing temperature, or adding soap, or decreasing volume, or both 1 and 2. The correct answer is option 4. The surface tension decreases with increasing temperature because the kinetic energy of the particles increases, reducing the effectiveness of the cohesive forces. Adding soap, or any surfactant, to water also decreases its surface tension. Surfactants are substances that tend to reduce the surface tension of a liquid. Decreasing the volume of the liquid does not affect the surface tension, as it is a property of the liquid itself and not its quantity. What is viscosity of liquid? Viscosity is a measure of a liquid's resistance to flow. It describes how thick or thin a liquid is and how easily it can move. The higher the viscosity, the thicker the liquid and the more resistance it has to flow. Conversely, a lower viscosity means the liquid is thinner and flows more easily. What causes the viscosity? The viscosity arises from the internal friction between molecules in a liquid. This friction opposes the movement of the liquid. How temperature affects viscosity? The viscosity of liquids generally decreases with an increase in temperature. As the temperature rises, the molecules move faster and can overcome intermolecular forces more easily, leading to a decrease in viscosity. The viscosity is typically independent of pressure or varies very little with pressure. Stronger intermolecular forces result in higher viscosity as the molecules find it more difficult to slide over each other. Molecules with a more complex shape or larger size usually have higher viscosity due to increased interactions between the molecules. Newton's law of viscosity states that the shear stress between adjacent fluid layers is proportional to the negative gradient of velocity in the direction perpendicular to the layers. Non-Newtonian fluids are fluids that do not follow Newton's law of viscosity, i.e., the viscosity changes with the rate of shear strain. Here are some examples of viscous flow. Honey versus water. Honey has a much higher viscosity than water. If you pour both from a container, honey flows slowly and thickly, while water flows quickly and easily. Second example is motor oil. Motor oil is designed to have a specific viscosity to ensure it can lubricate engine parts effectively. In cold temperatures, oil can become thicker, higher viscosity, which is why multigrade oils are used to maintain performance across temperature ranges. Glycerin is another example of a liquid with high viscosity. It flows very slowly compared to water due to strong intermolecular forces. Maple syrup has a higher viscosity than water but lower than honey. It flows more slowly than water but faster than honey. Some practical applications are: viscous liquids are used in lubrication. In machinery, the right viscosity of lubricants is crucial to reduce friction and wear between moving parts. In food industry, the viscosity of sauces, syrups, and other food products affects their texture and how they are used in cooking. In medicine, the viscosity of blood is an important factor in medical diagnostics and treatments. Now the question is, which of the following factors would increase the viscosity of a liquid? The correct answer is option 4. Viscosity of a liquid increases with a decrease in temperature because the kinetic energy of the particles decreases, enhancing the effectiveness of the cohesive forces. Adding a solute to a liquid also increases its viscosity as the solute particles obstruct the flow of the liquid particles. Temperature plays profound effect on liquid properties. Vapor pressure increases with temperature. As temperature rises, more molecules have enough kinetic energy to overcome intermolecular forces and escape into the vapor phase, increasing the vapor pressure. For liquids, as the temperature increases, the viscosity decreases. Higher temperatures provide the molecules with more kinetic energy to overcome the intermolecular forces that keep them aligned, thus allowing them to move more freely and reducing the viscosity. Surface tension decreases with the increase in temperature. As temperature increases, the kinetic energy of the molecules increases, which weakens the intermolecular forces, thereby reducing the surface tension. The effects of temperature on vapor pressure, viscosity, and surface tension are interconnected. They all stem from the impact of temperature on the kinetic energy of the molecules and the strength of the intermolecular forces. This takes us to the end of the video. Also look into our apps on Google Play for more information on this topic. Thank you for watching. If you liked this video, please subscribe to our YouTube channel.